Hello, welcome to everyone. In this video, this is our lecture number 21. 20 lecture we actually covered, and actually we discuss solve the problem asked in thermal physics of two books. First one is the thermal physics by Roy Gupta, and another one is the thermal physics by Garbansal Ghosh. This is the part 10 of this book, and rest of the lecture consists the solution of the another book, that is the Garbansal Ghosh. So if you want to watch the previous lecture, you can go through the description box, link are given there, and there is another separate playlist for theoretical part. You also go through the description box, link are given there. In this video we want to discuss about the question number 14 to question number 26, that is the first law of thermodynamics of chapter 6 of this book, right? So let's start with question number 14, which says that after denotation of an atom bomb, so that means when the atom bomb is blast, that is the ball of the fire consists of the spherical mass of gas found to be this. So when this bomb is blast, this makes a spherical bulb of gas, right, whose radius is like that and temperature is this. So assuming this is the adiabatic condition, because this is a very fast process, so you can take this as a adiabatic process. You know, for isothermal process this is very slow process, and adiabatic process is very fast. Since this is a very fast process, you can take this is as a adiabatic process, right? So find the radius of the ball after 100 millisecond when the temperature is like that and gamma is like that. So you can see here this is adiabatic process, so p v to the gamma equal to constant. Convert this p into times of v and t, this is RT by v. If you put, you'll be get the relation between temperature and volume with like that. So this is T1 V1 and this is T2 V2 like that. So V2 by V1 equals to the T1 by T2 in this. So this is the volume 4 third pi RQ, and this is 4 third pi RQ, and the temperature will be like that. So finally you will be get this expression, and this volume can be written as for the paragraph. So R2 by R1. So finally you will be get this relation R2 equal to 10 R1, and R1 equals to 15.24 meter. Multiply by 10, you will be get 152.4 second. So this time is not required for this calculation. I think clear. With the time increase, this radius will be increased, and the temperature also increases. You can see here decreases, temperature decreases and volume increases, temperature decreases, volume increases, right? Go to the next one. Next question says, if bubble formed at the bottom of pond quadruple their size after rising the top of the surface. That means when this is volume V1, here the volume will be quadruple, means 4 times. Dipole is 2 times, quadruple is 4 times, octupole is 8 times. So this volume here is 4 times compared to that one. Okay. So from the relation PV equal to nRT, you can see here PV by T equal to constant. So P1 V1 by T1 equal to P2 V2 by T2. You can see here this P2 equal to 4 V1. So V1 V1 cancel out. So P1 by P2 equals to like that. Just put this value of T1 and T2, that is 283 Kelvin and 293 Kelvin. Okay. So if you put this value, you will get this relation P1 equal to 3.86 P2. If there is a no error, this is the value. Now you can see here this here the pressure will be the two pressure, that is 1 atmospheric pressure plus the pressure due to the water. So pressure due to the water is H rho g, 1 atmospheric pressure, and here the pressure will be 3. You can see here the 3.86 P2. P2 is the 1 atmospheric pressure. So you will be rearrange them. Rho is the 1000 in SI unit, and this is 9.8. And if you minus this one, 2.86, and 1 atmospheric pressure is that Newton per meter square. So H equals to this one by that one. We will be get this one 29.56 meter. I think clear. Next one. Calculate the fall in temperature of atmosphere per kilometer changes in its height, assuming it to be perfectly dry, given that gamma z are equal to like that, and the mean molecular weight of 26 29. So you know the adiabatic lapse rate equal to like that. You can derive this expression. You can see here, you know the relation between temperature and pressure for the adiabatic adiabatic process equal to like that. P v to their gamma equal to constant. You can rearrange this equation, right? So if you take logarithm in both sides, you will be get this one. After rearranging then and then derivative, you will be get this one. And after rearranging then and then integrating, you can change this pressure equals to like that, P equal to you can see here that is the rho g dh by p divided by p both side. So you can see, if you multiply v here and this v here, pv equals to rt, and rho into v is mass. So dp by p equal to minus gm by rt dh. So if you put here gm by rt dh and right hand side is like that, so dt by dh, you can see here this tt cancel out, minus gamma minus 1 by gamma gm by r. Okay, so this relation actually used here, to determine this temperature increases, temperature fall in temperature, because there is a minus. So dt equals to dth multiply here, so you can see gamma equals to 1.4, g equals to 9.81, r equals to 8.30, and m equals to 29, and dh is the height change is kilometer. So here this will be that degree per kilometer. You can take this as degree centigrade or degree Kelvin, because you know the change in temperature in centigrade scale and Kelvin scale are equal. The actual value will be different, but change is equal. Go to the next one. Next question says the sound velocity in air equals to like that. This is the velocity of sound in air at temperature is this. So that the ratio of the heat capacity is like that. Ratio of the heat capacity is the Cp by Cv, which is gamma. Gamma equal to Cp by Cv. You need to find out the gamma. You know the velocity of sound in air is root over gamma p by rho. According to the Laplace correction. Okay. In the Newton correction, this will the gamma. They take this as a isothermal process. He write down this is p by rho, but actually this is very fast process. When the sound is transmitted from one point to another point, this is a very fast process. That's why this is taken as the adiabatic process by Laplace, and that's why this expression, velocity expression, is equal to root over gamma p by rho. So the gamma equals to nothing but v square p rho by p, and you know rho equals to m by v. So pv equals to rt. So put this value of v, m, r, and t. So finally you will be get this is the value of gamma. Clear? Next one. Go to the next one. Next question says a thin walled metal bulb VB, volume VB, contain a gas of high pressure and a capillary tube of stopcock is fitted on it. When the stopcock is opened slightly, the gas leaks slowly into cylindrical equipment of non-leakaging frictionless piston, whereas pressure remain constant. So the whole process depend on the pressure is the constant P0. So that the after as much gas is possible leaked out, the amount of work done equals to like that. So you know the work done equals to nothing but integration P dV. P is the constant because the pressure is constant. So P is the constant, so integration dV Vb is the initial volume and final volume is the V naught. So this is the P0 V naught minus Vb. Clear? I think this is very easy, very easy. So let's start. Let's go to the next question. Next question says the tension in a metallic wire is 1 meter long. This is the length and this is the area, increased quasi-statically at 0 degree centigrade from this to that. So this force increases from that to that one. You need to find out the work done. Okay. So you know the Young's modulus equals to force per area, length increased by initial length. So rearranging then you will be get L equals to FL by AW. So if you change small change, applying small force, so this will be the value. So dl can be replaced at L by ay df. So L a y is constant, f is integrated. So this is f square by 2. So this 2 here and final initial to final. If you take this initial as a f1 and final as a f2, so this will be the formula. And you can see this is the f1 and this is the f2. So if you put this value f1 f2 and finally you will be get this relation. So this is the work done, this is the work done of this process. Clear? Very simple. Go to the next one. This minus indicate this work done by the system on the system. This things is here. Next question. Next question says the equation of state of an ideal electrolyte is given by this. Okay, K is constant, H temperature, L0 is the value of L at tension is 0. The function of temperature only. Calculate the work done required to compress from this length to that one. So work done equals to FDL. You can put this F value here and integrating with this L. So after integrating, if you just put this limit from L0 to L0 by 2, you can easily find out this amount of work done. This here also by the system on the system happening here. Go to next one. Next question says the molar heat capacity at constant pressure Cp is the given like that A plus Bt minus C by T square. So that the amount of heat transferred during the isobaric process in which n mole of gas undergo temperature Ti to Ta, initial temperature, and this is final temperature. So you know the heat equal to Ncp dt. So Ncp is like that and dt. In here the integration a t, so 3a minus ti, and this is t square by 2, so by 2, and this is minus 1 by t, so this becomes plus 1 by t equal to like. So finally we will get this answer. There is a mistake in this, there will be minus here, otherwise this is plus. If this is minus, this is plus. If this is plus, this is minus. Clear? Next one. Sorry, this is minus, then this is minus. If this is plus, this is plus. Next one. Next question says 3 mole of ideal gas. The mole number is 3. Ideal gas bring initially at temperature this. This is the initial temperature. Isothermally expand 5 times initial volume. So final volume is 5 times the initial volume. Isochorically heated. Isochorically heated so that the pressure is the initial state is the initial state. So this is isothermally increase the volume, then isochorically reaches the initial pressure. Okay, so this is the diagram, PV diagram. The total amount of heat transfer to the gas during this process is this. So Q is like that, you need to find out the gamma. So you need to find out the total heat in this process, then equating with 80 kilojoule, then you can find the value of gamma. So the pressure at this point Pi equal to nRT0 by Vi. So this is the pressure. And the heat transfer during this process equals to Cv dt. So du equals to 0 because of this is isothermal process. So dq equals to dw. Okay. So dw equal to nRT ln Vf by Vi. This is the isothermal process work done. So n equals to 3, r equals to r, t is this, and ln Vf by Vi. Vf by Vi. So this is 5. Okay. So this is 5 times, so this is ln v, that is 5. And isochorically and this process, in the isochoric process, this dq equal to dv equal dw equals to 0 because this is p dv. Since dv is 0, so work done part is 0, so dq equal to cv dt. And you know cv equal to r by gamma minus 1, and dt is the final temperature minus initial temperature. So you can see here, so 5 vi by pi vi by 3r. You can see here pi vi by 3r is 273. So this is 5 into 273 and this is 273. So 5 minus 1, like that. Okay. So the total heat will be addition of these two things. So total heat is the addition of these two things. You will be get the 80 kilojoule. So if you compare with 80, so finally we get the gamma value is 1.13. But the answer is 1.4. So if anyone find out this answer, if there is any error, you must comment in the comment box. Go to the next one. For a thermodynamic system, U is given here, and so that the equation of the adiabatic in PV plane is given V to the power 7, P to the power 5 as a constant. Okay. From the first law of thermodynamics, dq equals to du plus dw. So for adiabatic dq equals to 0 and du plus dw equals to 0, because from first law dq equals to du plus dw, but in adiabatic process dq equals to 0, that's why du plus dw equals to 0. So you will be get this expression, you will be put this value du equal to this one, u equals to this one, so just derivative you will put this value and rearranging, then will be get this one, and then integrating I will be easily find out this relation. Simple. Next one. Next question says, suppose 1 mole of ideal gas, the mole number is 1, subjected to the cyclic quasi-static process appears as a PV diagram. So this is the PV diagram in this equation, so that the net work done by the gas in one cycle is like that. So for this one cycle, neat work done will be 314 joule. You need to find out. You know the work done during a cyclic process is the area under the enclosed by the car. So the area of this car will be pi into, this is like a ellipse, so pi AB like that. So pi into this half of this semi major axis and the half of the semi minor axis. So you can see here this is 3, this is 1. So 3 minus 1 by 2 half, this is 3 minus 1 by 2, and this is 10 to the power 3. And for BD this is 3, this is 1. So this is 3 minus 1 by 2, and this is 10 to the power 6. So if you rearranging them, you can easily find out this arc. And you know 10 to the power 7 arc is 1 joule. So if you take 10 to the power 2 here, so this is 314 joule. Clear? Next one says the internal energy difference of the gas between C and A is about like that. So you need to find out the internal energy strength from that one to that one. You know internal energy change is nothing but CV dt. So the temperature change will be the important here. So you need to take find out the temperature at A point and find out the temperature at B point. After that you take this difference, you will be get the change in internal energy. You can see here temperature A is nothing but PA VA by NR. So PA VA NR. Just put this value from the graph, and R value is like that. For this is CGS unit, that's why R taken as CGS unit. And for temperature at point C, this similar process you will be get this to temperature. Okay. So change in internal energy is nothing but CV 3 by 2 RT. And for this is the ideal gas subject to this 1 mole of ideal gas. So this is take as a gas. So the monoatomic gas 3 by 2 R. This is take as a 3 by 2 R monoatomic gas. If you take this okay, here CV is given here 3 by 2 R. So use this 3 by 2 R dt temperature difference. So just taking this difference, you can see this 8.314 are cancel out, will be get 600 joule of the. So the internal energy from A point to B point are obtained. Now heat absorbed by the gas going A to C via ABC path. So the heat absorbed during this path will be nothing but the work done during the path plus internal energy change. So you need to find out the work done. You know the work done is nothing but the area under the total curve. So you can see here there is a half portion plus it is rectangle. So the half of this area of this circle or ellipse plus rectangle. So this area already find out 314 in the first question. This is 314 joule. So if you put the here, this is 314 by half by 2, 157. And area of this one, you can say this is 3 1. So that is 2 into 10 to the 3, and this is also 2 like that. So this is the work done in this process. So the heat is nothing but du plus dw. Du is given here, du is given here 600, and dw equals to like that. So finally you will be get the total heat of this process. Okay, so that's it of this question. Clear? Go to the next one. Next question says the PV diagram represent the ideal monoatomic gas for 1 mole of gas. Calculate in terms of R the temperature at this 4 points. So you need to find out the temperature at A, B, C, D. So the temperature at A point is PV by NR. So pressure at this point is 80 kilo. That's why 10 to the power 3. Volume is this, and N into R. N is 1 mole. So this is the temperatures at point A. Similarly for B, similarly for C, similarly for D. Clear? That's it. Next portion says also calculate the heat reject and absorb during the circle and the efficiency of the circle. So for each process we take count the heat. For this one, this work done equals to 0. This is because this is the no volume change. So this part is 0, only Cv dt, and Cv is R by gamma minus 1 dt. So R by gamma minus 1, gamma is 5 by 3. So gamma minus R equal to 2 by 3. That is 3 by 2 R. Cv equals to 3 by 2 R here. And temperature difference between these two. So just putting this value of temperature difference, we will be get positive heat, that is mean absorb. For BC path also find out the similar process. Du equal to like that, and P work done of this process pressure into the volume change. So this will be the heat in during this process. These two are positive, that's why heat absorb about like that. This answer is does not match with this answer, but I cannot find any error. And for CD this is also like that. For CD this is also like that. And DA, sorry, CD there is no work done. CD there is no work done, only CBDT. And for DA there is work done, and these two are minus. So this is the heat reject. This pressure increase, work positive. This is volume increase, work positive. This is pressure decrease, work negative. This is our heat negative, heat reject. And this is volume negative, heat reject. So the total rejected heat is Q2, and total absorbed heat as a taken as Q1. So the efficiency is nothing but 1 minus Q2 by Q1. So this is the efficiency. This formula actually will be obtained in second law of thermodynamics, but you can remember that is the eta, that is the efficiency is nothing but W by Q1. Actually, if you take, this is a temperature T1, that is called source, and this is the temperature T2, that is called sink. Always source temperature is greater than sink, and then this amount heat absorbed from the source, the engine work done some work, and rest of the heat transmitted to sink. This is the process. So efficiency of this engine is nothing but work done by heat absorbed. So this W is nothing but Q1 minus Q2. W is nothing but Q1 minus Q2. Here you can see here Q1 is used as work done plus Q2. So W equal to Q1 minus Q2. So this is 1 minus Q2 by Q1. So you just put this expression in this equation. You can easily find out the efficiency of this equation. Okay. So next question. A cylinder contain 1 mole of oxygen. So N is 1, oxygen, so the gamma is for diatomic 7 by 5. Temperature is 27 degrees centigrade. So this 70 degrees centigrade converted into Kelvin. So 300 Kelvin. The cylinder is provided with a frictionless piston such that it maintains a pressure of 1 atmosphere on the gas. So the pressure is 1 atm. The gas is heated until its temperature raises to 127 degrees centigrade. Draw a diagram representing the process in a PV diagram so that the work done is about 831. The change in internal energy is about 2110 joule. Find the heat supply to the gas. What will be the work done in this? So you can see here. So first you need to draw this process. Since this pressure is constant, so this isobaric process, right? So the work done equals to PdV. So pressure is constant, volume change. So volume Vm minus Va. And you know this PV equal to RT. So RTA minus RTI. So the temperature change. So this is the work done. And internal energy about like that. Internal energy Cv dt, Cv equal to R by gamma minus 1, T minus Ti. R gamma is 7 by 5 because this is the oxygen diatomic. So this is 7 minus 5. So this is the internal energy change. So next, the find the heat supply of this gas. Heat is nothing but du plus dw. Du is this, and dw is 3831. So finally, dq equals to this one. So work done for when this pressure is 0.5. Next question is, when the pressure is 0.5, what will be the work done? What will be the work done? Okay. Since there is a volume is not important here, the temperature is important, so the work done expression will be like that. And in this expression there is no expression of pressure, so the energy work done will be the same for the reduction of pressure if the temperature difference will be the same. Okay, there is no other condition said here, so we take this temperature difference is same, that's why the work done also the same. Clear? I think clear. If there is any doubt, you must comment in the comment box. This is all about me. This is my contact detail. You can connect with me with this Telegram channel, and this is my other online platform. And this is my YouTube channel details. Go to this channel, you will get different physics related videos on mathematics. Like this session if you learn something from this session, and share this video to your friends. Either he or she also get benefit from this video. Subscribe this channel if you're new in this channel. Those already subscribed, thanks for subscription. Press the bell icon to get the notification of upcoming videos. So take care. We'll meet in the next video as soon as possible. Thank you.